Hello, I will now do the demo for the mini project. The mini project I have chosen is COVID-19 face mask detector with OpenCV. This project uses OpenCV, TensorFlow, Keras, and Deep Learning to detect whether a face mask is present on a face or not. So let's take a look at the dataset. The dataset consists of images, faces with mask and without masks. These are the faces without masks. There are around 600 of those. These are the faces with masks. Around 600 of those too. And the masks have been digitally edited into the pictures due to the lack of faces with masks. And let's take a look at the scripts. There is the detect image mask, mask image, detect mask video, and detect train mask detector. This is a script that we'll use to train the model. So first, it imports the necessary packages such as TensorFlow for data augmentation, pre-processing, and to use a mobile V2 model. Here we construct the argument parser, which will take the dataset for the training and will show where it will show the output path for the model. Let's take a look at the deep learning parameters. There is learning rate, the epoch, and the batch size of 32. So firstly, we'll initialize to array for storing the labels and the data. Here we loop over the path of the images, that is, all the images will be loaded into this, and the labels, it will hold the status of the image, that is, with mask or without mask. So it will load the image and reprocess the input, and then we'll append it to the array, and then it will convert the array to NumPy arrays. And then we'll perform one hot encoding on the labels. Here we'll split the data set. So we'll use 20% for testing and 80% for the training. So now we'll construct the training image generator for data augmentation. This is the mobile net P2 model. This is the activation function in different layers. Model, and here we'll start we'll loop over the model. Here we'll compile our model, and here we'll start the training for the model. After the model has this is for the training, and after the model will have been trained, we'll make the prediction on the test of 20% of all the images. Finally, we'll save the model onto disk. So let's take a look at how we train the model. Here we'll pause the dataset, and here's the model will train. In the folder there is no model yet, and the model will appear here, because this is the default location of where the model should be when we do not pass it. So now the model is being trained. Now the model will start training. In my report, I have included the code for the model, for the three scripts, and I have shown how the model is being trained at different stages. And after it has been trained. So I will skip over this part for now because the training takes a lot of time, around 20 minutes or so. So I will pause it and come back after the model has been trained. We are in the middle of the training process. I just wanted to show a little bit of the training. Training is still being done. We are still in the middle of the training process. At this point, the training is nearly done. We are on the 17th epoch. The model has now finished training, and as you can see, it has achieved an accuracy of nearly 100%, of around 99%. And here is the model. It has been saved onto the disk. Now let's take a look at the detect mask image. The first field has the imports, the argument parser to parse the image in the model, which is this is the default model. It will be parsed automatically, and then we'll load our serialized face the detector from the disk. We'll load the model from the disk again, and then we'll load the input image from disk, and we'll clone it. So here we'll make an image of a copy of the image. We'll construct a blob from that copy of the image. No, from the original image. I'm sorry. Then we'll pass the blob through the network and obtain the face detection. So we'll loop over the detections. We'll filter out weak detentions. This is done. It is on the minimum confidence. This is done to ensure that we have only faces in our image. This is for the checking if we have an image. This is why we use the confidence for. So here is a box. It is a bounding box that we'll use to look if a face is present. And here we check to ensure that the face is present in the frame of the image. And here we'll extract the face ORI, the region of interest, which is a face. And we'll do some processing on it, and we'll pass the face to the model to predict. And here the model will draw the box, which is a red, and shows the probability here. It is red when there is no image, there's no face mask detected, and green when a face mask is detected. So let's take a look at the detection. So we'll test with an image, with this image. It has a face mask on it. Detected a mask at 99.97%. Percentage to show it. Now let's test another image. Test a second image. This one does not have a mask, and it detects that there's no mask present. Let's test another image again. So here it detects the two faces, but it does not detect the woman in the front. It's because in our dataset, which we use for the test for the training, there is no image in which there is a face in the foreground. There's only faces in the background. This is why I could not detect the face of the image, the mask, the face in the image. Yes. We'll test with another image again. And here it detected the mask. These are the images we tested with. All the images did not have a box which said whether or not there was a mask on it. But after the script has run, it shows that the box was drawn into the faces. And lastly, we have the train, the detect mask video. But it is very similar to the detect mask image.py. It basically takes a frame of the image and then checks it. So it will use, we will import this for the to use a webcam, and we will report time for sleeping. So we will first create a function. We take three parameters, that is the frame, the model, and the FaceNet model and the MaskNet model. And it will loop over this code over, or similar to the ones in the detect mask image. These are the argument parser. We load our detector. Here we initialize the video stream. And here, while it is true, we will continuously call this function to detect whether or not there is a mask on a face, the camera stream. Camera stream will basically take a frame, which is just like an image. So now let's do the testing on the camera. I will now demo the detect mask video.py as a script for detecting a mask on video on the webcam. Here we can see that the program runs and it does not detect a mask on my face. And I will now put a mask on my face to see the result. The model has detected a mask on my face. And now it detects that I no longer have a mask on my face. So this has been the demonstration of the mini project.